All right, this is lesson 12-1, and I hope you have a clean copy of these notes in front of you, and I'd like you to try all 5 problems on them after pausing this video. So pause the video, try all 5 problems, and then resume the video. Go. All right, let's talk about my solutions to these problems. There's a difference between perimeter and area. Right? Perimeter is a distance. It's fundamentally a length, and it's the length around a polygon, whether it's 4 sides, 5 sides, or whatever. You add up all the sides going around. No side lengths, cutting through the middle or anything like that. No diagonals, just the sides going around. Since this is a rectangle, this side would also be 8 here, and this side would also be 30. So you add a couple of 8s and a couple of 30s, and you get 76. I asked for units with the answers. So this would be 76 inches on a quiz or a test. If I ask for units and you don't include them, you're going to lose credit, right? Here's a formula I'm sure you are familiar with for area of a rectangle. Okay, area equals base times height is how I'm presenting it. You might be more used to calling the formula area is equal to length times width, which is not incorrect, all right, if you say area is equal to length times width. But I'm going to continue using the terms base and height. In geometry, when we talk about a base and a height of an object, some polygon, we're talking about 2 lengths that must be at right angles to each other. Length and width are not necessarily at right angles to each other. Okay, so there's a difference between the terms. In rectangles, there really is no difference, but in other polygons, there is a difference. And base and height are the terms and the lengths that we're going to need in our formula. So I want you to get used to those terms right away. Base and a height must be at right angles to each other. That's what we mean by base and height. Okay? If you use length and width, you get the same answer. More importantly to this problem is the units. The units are square inches. Now look at the math here. The base is 30 inches. It's not just 30, it's 30 inches. And the height is 8 inches. And when you multiply 30 times 8, you get 240. When you multiply inches times inches, you get inches squared, just as if you were multiplying, let's say, 30x times 8x. You'd multiply the 30 times 8 and get 240. You'd multiply the x times x and get x squared. So that's where inches squared, or square inches, is a perfectly acceptable way to say that also. That's where that comes from multiplying the inches unit in one dimension by the inches unit in the other dimension. Okay, once again, if I ask for units for answers and you don't give them, or you give the wrong units, it's going to be marked wrong. Problems 2, 3, and 4 were the same problem, but I asked you to try to find 3 different ways to do it, and here are my 3 different ways. The first 2 ways I would describe really as the same type of strategy. I'd call it a divide and add strategy, where you divide this sort of L-shaped piece into 2 rectangular pieces, find the area of each piece and add them together. You can see we get the same answer either way. That's good. We don't get the same answer. We've done it wrong at least one of those 2 ways, right? But you got to be careful about the dimensions here, right? This total height of this rectangle is this 20 plus this 18. The width of this rectangle here is this 50 minus that 15. Okay, so be careful about the dimensions. If we divide this rectangle up horizontally instead of vertically, we get different rectangles with different dimensions, but the total area adds up to be the same, as it should. Once again, the rectangle at the bottom, although it is 18 inches tall, is only 35 inches wide because it's this 50 minus this 15. Now, at the bottom of the page is a really fundamentally different strategy. I would refer to it as a subtracting strategy rather than an adding strategy. So what we do is pretend that there is a solid rectangle here in red. Okay, it's sort of like fill in this hole here, this black hole in the lower left-hand corner, and pretend we have a solid rectangle whose dimensions are 50 by 38. That would be an area of 1900, but then that's too much area. Subtract that hole there, whose dimensions are 15 by 18, for an area of 270. Subtract that 270 from the 1900, and you get the same answer as the first two, 1630 square inches, or inches squared. I give you a problem like this, which I will. I don't care what strategy you use, but in general, keep this subtracting strategy in mind as an option, because I think, at least for me, a lot of students' instinct when they're first solving a variety of problems like these is to use a divide and add strategy, which in many cases is fine. But if using a subtracting strategy never occurs to you, some problems are going to be really difficult, trying to divide shapes into rectangular pieces and add them together. So be aware of subtracting as a strategy. On the homework tonight, there is at least one problem that would be made way, way easier if you are thinking about subtracting as a strategy. Last problem. Which of these would have an area closest to 2,000 square inches? I wonder if you had any idea how to do this problem or what the correct answer would be to this problem. Let me give you a strategy for this. Invent a rectangle whose area would be 2,000 square inches, right? Come up with dimensions for a rectangle, and come up with not just any dimensions, but dimensions that would be close to square. Like, I could think of dimensions that would make a 2,000 square inch rectangle. That would be easy. 1 inch by 2,000 inches. Okay? The problem is none of these rectangular shapes are anything like 1 inch by 2,000 inches. Okay, that's an extremely narrow and long rectangle. Most of these rectangles are much closer to square than they are to this. Well, how about 2 inches by 1,000 inches? Still way, way too long. So how do you get dimensions that are close to square? Well, arithmetically, that can be a challenge. So pick up a calculator and find the square root of 2,000. Right? What is the square root of 2,000? Well, it's about, I think, 44.7. Well, that's not a nice number. I don't like that. So I'm going to try dividing 2,000 by 45. See if that gives me a nice whole number answer. Well, it doesn't. Okay, so I'm going to try dividing 2,000 by 40 or 50. Let's try 40. Well, that comes out to be a nice whole number, 50. So right there's dimensions of a rectangle that are much closer to square than 1 by 2,000 that might help me solve this problem. So 40 inches by 50 inches, that would be a 2,000 square inch rectangle. Now, the problem still is a lot of people can't judge how long 40 inches or 50 inches is. Some of you maybe can, and might be a lot closer to deciding which of these is the best answer than you were before. But maybe if we converted those inches into feet, I know you all know there are 12 inches in a foot. You are expected to know that, okay? So if we convert 40 inches into feet, we're going to get 3.3 repeating feet. If we divide 50 inches into feet, we're going to get 4.16 repeating feet. So let's redraw the rectangle. 3.3 feet by 4.16 feet. Now I think you can judge which one of these shapes has an area that's closest to this. Notice it says closest, not exactly. Okay. Your computer screen, 3 feet by 4 feet. Come on, your computer screen is barely 1 foot wide, and it's not even 1 foot tall. Your kitchen table, Yeah, that might, I mean, kitchen tables vary in sizes quite a bit, I understand. But a kitchen table is much more likely to be 3 feet by 4 feet than your computer screen. And by the time you get to your bedroom floor, well, your bedroom floor is way larger than 3 feet by 4 feet. I mean, your bedroom, not your bedroom, your bed itself is larger than 3 feet, but you wouldn't be able to fit on your bed. You're all probably at least 5 feet tall, almost all of you. Well, some of you are still trying to reach 5 feet, but right, you're all longer. You're all taller than 4.1 feet. That's for sure. Okay. So, and then the basketball court and the football field are just ridiculous. So, your kitchen table is really the best answer. So, what's the strategy here? Find dimensions for a rectangle and try to get those dimensions to be as close to square as possible, as close to equal each other as possible. And the way to do that is to take the square root of the area figure you've been given and then move from that square root to the nearest nice whole numbers, right? And divide that area by, whole numbers that are really close until you find dimensions that are nice whole numbers, just to have nice numbers to work with. I mean, you don't have to have nice numbers to work with. You could call this area 44.7 inches by 44.7 inches. And then again, divide those by 12 to find out how many feet those are. And that could work. You don't need whole numbers. It's just that most of us like working with whole numbers much of the time. Makes us a little more comfortable, a little less intimidating. Sometimes makes you feel like you're doing the problem right. Okay, that's the lesson for today. Good luck on the homework. We'll see you next time.